All righty. Okay. So what we're looking at today is how to solve using the quadratic formula. And we're only going to get to this part. So this is the assignment, the 3U. Gentlemen, just 3U. We're going to do this the next day. All right. So quadratic formula. X equals the opposite of B plus or minus B squared minus 4AC by 2A. That's the quadratic formula. And A, B, and C are just your coefficients. All right. So where did that thing come from? Some smart person just... So when a formula is developed, I mean, the quadratic formula is probably one of the most famous formulas that are out there. Okay, this formula right here. Okay, and then here's an example of how you use it. Your A, B, and C are just your coefficients. This is on the back. This is the coefficient on your squared term. This is the coefficient on the linear term. And then the C is the constant. Now, I told you we were going to program your calculators. So I tried it on the Chromebooks and the programs don't save. So I programmed it, and then when I close the book and open it again, the program's no longer in the calculator. So there's really no sense programming it, unfortunately. So that was kind of a disappointment. All right, so this formula, the question is, where did it come from? Outer space? Aliens that visited us years? Pythagorean theorem? All right. Okay. So we know what the general form of an equation is. So what you guys are going to discover right here is where this formula actually came from. So your teachers probably gave you the formula. I don't know if they showed you, well, did it just come out of thin air? Some smart person just decided, hey, I'm just going to write this out, and it's going to give me the roots of an equation. Well, these guys are way smarter than me, that's for sure. No, I'm good at faking it. Okay, so. All right. So we're going to take the general form. Remember, we learned 3 different forms of a quadratic: vertex form, intercept form, and general form. Okay, so we're going to take this general form equation and we're going to perform the process of completing the square on it. So completing the square is what we've been doing for the last couple of days. All right, so when you square, the first thing that you do is you move the constant to the other side. So over here, I'm giving you the instructions. RHS just means right-hand side. All right, so I'm going to have AX squared plus BX, leave a little bit of space, equals negative C. So I'm just using, I'm doing exactly what we did in the notes where I'm following this recipe right here. Move the constant to the other side. Divide by the leading coefficient if necessary. That's exactly what we're doing, but we're just doing it to a generic equation. Okay, so now divide both sides by A. So I'm going to end up, I'll have ax squared plus bx equals negative c. And now I'm going to divide everything by a. And I end up with x squared plus bx over a space equals negative c over a. So we did the second part. We divided by the leading coefficient. All right. Now we're taking, we take half of the coefficient on the linear term. Okay, so the coefficient on the linear term here, guys, is the fraction b over a. So I did it right over here. I took b over a and I divided it by 2. Well, that's the same as b over a times 1/2. And then I squared it. Okay, so when I multiply that by 1/2, I get, and I square it, okay, I have 2a. That's when I multiply these two together. I'll do it right here. This would be b over 2a squared. So that's going to become b squared over 4a squared. So this is the number that when we took half of the middle term and then we squared it. All right, so we got to add that to both sides. All right, so over here, we're going to have x squared plus b over ax plus b squared over 4a squared. And then I'm going to add that to the other side. Equals negative c over a plus b squared over 4a squared. So all we're doing is completing the square, except we don't have values for the coefficients, we have variables. All right, so we just did part 3. We added it to both sides. Okay, next step says reorder the right-hand side. So we're going to rewrite this with the b squared first and the minus ca second. Okay, so we got x squared. We're just going to copy the right-hand side, the left-hand side. Copy that. So x squared plus b over ax plus b squared. Now stop me if I do a step and you don't know what I'm doing. B squared over 4a squared minus c over a. So I just took the right-hand side and I reordered it. Just switch the order. Okay. All right, so we did that. Okay, now what we're going to do is we're going to find a common denominator for this so we can put it together. All right. So find a common denominator for this part right here. 4a squared. Okay. So what it's going to be, the common denominator is going to end up being 4a squared. Okay. All right. So when I do that, I can add these two up. Where I'm going to have x plus. Okay, and now my common denominator is 4a squared. Okay, so to add these two up, we'll do it right here. Okay, right? Okay, and we got, so this first term, I don't have to do anything to it. It has the denominator that I want. So that b squared is just going to stay b squared. Term, what do I got to multiply it by? Okay, so that's going to be minus 4ac. Starting to look a little bit more like the quadratic formula. B squared minus 4ac is what's under the radical. All right, now factor the left-hand side. So it's like, I got to factor this. Yikes. But remember, that's a really quick factor. We know it's going to be squared x. Now, the term that goes there is whatever the middle term was when after I multiplied it by or divided it by 2. I highlighted it up here. That's what goes in my term right here. So it's going to be plus b over 2a. And then here, b squared minus 4ac divided by 4a. Okay, so from here to there, we factored it. And what we did right here is we just combined those. Okay, so we're still just following the complete square process. Okay, now we're going to take the square root of both sides. So over here, I'm going to have square root equals square root Okay, and now we simplify this. So these are just going to cancel. So I'm going to end up with x b over 2a equals, and now the square root here, okay, that is just 2 square roots. So the top and the bottom. The top I can't simplify, so that's going to stay the way it is. B squared minus 4AC divided by square root of 4 is 2. Square root of A squared is 8. Now solve for X. So all you got to do is move B over A. I'm gonna subtract B over 2A from both sides. So when I do that, I'll have X equals, when I subtract it over here, I'm going to have negative B over 2A plus or minus, okay, square root of B squared minus 4AC divided by 2A. And the denominators are the same. So opposite of B, plus or minus B squared minus 4AC all over 2A. That's where the quadratic formula comes from. So without the square, the quadratic formula would not exist. So, you know, usually like when I was learning I'm like, why would we use completing the square when I can just use the quadratic formula? It's quicker. That's true. And all I'm trying to show you here is without completing the square, there would be no quadratic formula. Just like without the Pythagorean theorem, there would be no trigonometry. And buildings wouldn't be staying up and bridges would be falling over and all sorts. We wouldn't have been able to put men on the moon. Or did you see what happened earlier this week, what NASA did? What? They landed hold on, they landed a rocket on an asteroid. And it collected a little bit of dirt, so it landed, and it had like a it landed, then it kind of churned up the surface a little bit, and it grabbed a handful of it, brought it back in, and then now it's on its way back. It was only on the asteroid for like 30 seconds or even less, like maybe 15. But if you think about the mathematics involved with finding an asteroid, reaching it, landing on it, leaving, and then coming back home, well, there's the trick. It's just mind-blowing. Mind-blowing. Because that asteroid is moving. It's not just, you know, hey, I got to go to the corner of Maine and whatever. I got to find a moving object that is moving throughout the universe. No, they calculate where the asteroid's going to be, and then they calculate how to intercept it, and it's pretty involved. Yeah, I'll find a clip. Okay. Oh, that was on, what was that on, Google Earth? Yeah, that's pretty cool. Yeah. Okay. All right. Now, so when you solve these other problems here are just a quick review of using the quadratic formula. Now, the big thing about the quadratic formula, if you turn to the next page here, is this quantity right down here. This b squared minus 4ac. This is, we get all sorts of clues about a quadratic by looking at that. Okay, that quantity right there, that expression is called the discriminant. Discriminant. And the discriminant is b squared minus 4ac. It's that expression. And looking at that discriminant, it tells us all sorts of things about a parabola without even drawing the parabola. Okay, when you solve a quadratic, okay, when you have solutions to a quadratic, you can have two unique or different solutions, two unique, or you could have one repeating solution, it repeats, or you could have zero solutions. So you could have two, one that is a repeating, it's the same, and then no solutions. All right. So real quick, we'll go through a couple of examples here. This is just going over how to plug it in. All right. So let's say we were doing B here. Okay, what we do is you get it in general form. So I just added 2 to both sides. And then that helps us tell what A, B, and C are. It's just the coefficients. A, B, C, and they're right here. A, B, okay, and then we plug it into the quadratic formula, which is the opposite of B, which would be negative 6 minus B squared so 6 squared minus 4, 3, 2, all divided by 2 times 2a. And then all it is just, you know, working the numbers. So I usually do this just all in one step. 36, take away 4 times 3 is 12, times 2, 24. So this is going to be root 12. Okay. And people are usually pretty good with this part, and then they simplify root 12, which is 2 root 3. Somebody said 3 root 2 yesterday during football practice. Yeah, no, there's no excuse.
I said 2 root 3.
I definitely heard 3 root 2, which was alarming. I was very concerned. Okay. So now what we end up with is 6 plus or minus 2 root 3 over 6. Okay, now, again, most people don't have any problem getting to this part. What gets confusing is getting from that to this sometimes. So how do you get from this to this? Yeah, there's two ways. One way is break it up into two separate fractions. Okay, so there's this method, which is, you can write this as negative 6 over 6 plus or minus 2 root 3 over 6. Okay, or you can factor the top. Okay, so the GCF of negative 6 and 2 would be 2, but I'm going to pull out a negative 2. So this would then be 3, where am I? Plus or minus, well, you know what? Let's bring out a 2 instead. So we don't have to change this up. Pull out a 2. We have negative 3 plus or minus all over 6. All right, now if you simplify this one on the top, okay, that would become negative 1 plus or minus, and then the 2 and the 6 you can reduce to root 3 over 3. Because the 2 and the 6 you can divide by 2. Now you'll get the exact same thing if you did it this way. Okay, 2 and the 6 reduced. And then if I broke that up into two fractions, I get the same answer. So you kind of can decide which one in this case is quicker. The split method or the factor method. Yeah, definitely the split method. Split it into two equal fractions and then simplify. So this one has two unique solutions. Negative 1 plus root 3 over 3 and negative 1 minus. That's two solutions. All right, next one here. Let's see what we got. Opposite of B. B is negative 7 now. So boom. So A is 6, B is negative, and C is negative 5. And then just opposite of negative 7. Okay. This is negative 7 squared. Now, if you do this on your calculator, you got to be careful because it'll give you the wrong answer unless you understand what's happening. Right. Minus 4AC. 4 times A times C divided by 2 times A. Okay, so if I was to do that on my calculator, you got to understand how the calculator thinks of this equation. My calculator. Okay. Okay, when I plug that in, guys, -7 squared all right, if I do -7 and I square it, okay, it's -7 squared. It says -49. All right, so you got to understand how exponents work. That 2 only affects the 7. That's really a -1 there. If you want to square -7, you got to put it in parentheses. -7.
How do you know which one?
When you want to square a negative, you're going to do it like this.
Is it like
What this is asking you to do is to square the value of -7. So to square the value of -7, you have to write it with the parentheses.
when would you?
Maybe if it was like an expression, let's say I had something like this. And I said, let x equal 7. Well, when you plug 7 in there, it looks like this. So this would be -49 plus 2. Now, if it was a problem that looked like this, let's say you were simplifying, and this was, x was -7. Then when you take out that x, you're putting in -7 and squaring it. Okay. The one thing you can do on the quadratic formula is just don't worry about the negative on that 7. You know, every time you plug this in, it's always going to be positive. But if I was doing this on my calculator, which most people do, or on my phone or whatever, okay, I would have that minus, okay, 4 times 6 times -5. And that's going to be my discriminant. $169, which is a perfect square. That's 13. So then you got two solutions. You can just leave it like that. That's fine. X is going to equal, because you can't do any simplifying here. Well, I guess you could. You can go 7 plus 13 over 12 and 7 minus 13 over 12. So 20 over 12, which is 10 over 6, which is 5 over 3. And then this one would be -6 over 12, which is -1. There's my two x-intercepts. Okay, now the one I really wanted to get to was this last one, because something weird happens with the discriminant. Okay, now, by the way, where it says here the solutions are not surds, what the heck is a surd? It's just another name for a radical. I didn't make this part. I copied that part from our book, and our book uses surds because it's published in England. So the rest of the world calls radicals surds. Why? Who knows? Sounds gross. Okay. Just another name for radical. Okay. All right, here we go. A, B, C, and let's do this real quick before we run out of time. So x equals plus or minus opposite of B. B is -4, so 4 plus or minus. Okay. B is, okay, so the value of B is -4. Okay, so this is the opposite of B, which is 4 plus or minus B squared minus 4 times A times C divided by 4 plus or minus, and A was 1. So that's just going to be 2. All right, now when you try to do that, -4 squared. So I know -4 squared is going to be positive, so I just type in 4 squared. Because I'm lazy and I don't want to type in the 2 parentheses with the negative. It's going to be the same thing. All right, then I'm going to go minus, whoops, minus 4. I got 1 and 5. Okay, 4 times 1 times 5. Boom. -4. All right, now -4, you can't simplify it. You can if you are allowed to use imaginary numbers. So right now we're saying we're restricting our values, because see, the square root of -4 is actually going to be 2i, which is an imaginary number. So the point here is, at this point, until we start using imaginary numbers, you write no real solutions. So this has 0 solutions. The solution isn't 0. There are no real solutions. X, or the quadratic, has no real solutions. Okay, so we could just say X does not exist because of the square root of -4. So that tells you when your discriminant is negative, you're not going to get any real solutions. Anybody know what this parabola would look like? Yeah, it's still a parabola. One half of it? No. If it doesn't have any real solutions, where does it cross the x-axis? It doesn't. So this would look something. So all of these parabolas would have no real solutions. It's like floating. It doesn't cross the x-axis. All right, so tonight you got 2, let's see, D, E, F, G, 4, A, B, C. All right, here, we'll cut one out. We'll make it due Monday.
Okay, thank you.